Guess what today is? It's the last video of your course. Congratulations, you did it. This is the last one. So let's get right into it. This is 8.4. We are again measuring the difference between two things and doing hypothesis tests, but now we're looking at population proportions. So remember that means this phrase right here means that our problems are binomial. So that means they are yes or no's. Often that means that they are going to have percentages in the problems. Not always, but often. So if you see percentages, you go, it might be a binomial, and you check it. Okay. So that means that in our claim, we're going to be using a P instead of a mu. That's going to be represent our population proportion, and we're going to be testing a claim about that. So let's jump right in. Here's our first problem. We're going to do this top one about exercising and socializing. So alpha is going to be 0.10. They want to know if you can reject the claim that the proportion of 18 to 24-year-olds who benefit from exercising is the same as those who benefit from socializing. So we have this chart over here. It says that exercising, we have 57% of people benefit from exercising, and then 51% socializing. And we want to know if that's statistically the same. So my claim is going to be that P1 equals P2, because that is what the same means. And also here's our keyword too, is. So those are equal, the proportion of exercising to socializing. So I'm saying that exercising is P1 and socializing is P2. Again, you get to choose how you want to do that, but then you've got to be consistent through the whole problem with what you pick. That's going to be our claim. And P1 not equal to P2 is going to be the complement. Equal is H naught, not equals HA. And HA is going to dictate our picture. So because it's not equal, it's going to be a two-tailed test. So that means I'm taking alpha, which is 0.10, and I'm dividing that by 2. And this is what our alpha is going to be. Half on each side. We can find a critical point if you'd like. We can do an inverse norm with an area of 0.05. That's my class calc people. Or if you're my, that's my TI people, our inverse norm in your distribution menu. Or if you're on class calc, we're going to go distribution plot, a normal distribution of 0 and 1. And then we're going to tack on our dot inverse CDF, and our area is 0.05. So I get a z-score of negative 1.64. And because this is symmetric, that means this is 1.64 as well. So that's our setup. Our rejection region is going to be any p value, p hat value that is less than 1.64, or a p hat that is bigger than 1.64. That's going to be our rejection region. And now let's go and jump to the calculator and do our tests. For my TI people, I lost my calculator. There it is. For my TI people, you're going to go into stat, into test. And mine is number 6. It says 2 prop Z interval. You're going to hit enter on that and fill in your information. I'm going to talk about it in a second. Let me get my class calc people in the right menu. They're asking for X1, N1, X2, N2, and then they're doing your little which way is your graph going thing. Okay. My class calc people, we are going to go to stat, and then we're going to go to test. And we're looking at this 2 prop Z test right here. And you also are being asked for X1N1, X2N2. Now, if you remember from the previous binomial problems, oh my gosh, I'm struggling keeping track of where I am. Sorry. X1 is the number of people who say yes to the situation. And again, we've talked about this. Yes means it may not actually be the word yes, but it's the affirmative to whatever your claim is. Okay. And this is not a percentage. It's the actual number of people that say yes. So the way you do that is you take your N times your N1, your sample size for the first group, and you multiply by your P hat 1, which is your percentage of people in that first sample that say yes. So in light of our problem, this right here is our P hat 1. The percentage of people that say yes, exercising helps me. And this is our P hat 2, the percentage of people that say yes, socializing helps me. Because remember, exercising is our P1, socializing is our P2. And in the directions is where we find our sample size. The percentages of a survey of 200 people. So our N1 is going to be 200 and N2 is going to be 200. Those numbers don't always have to be the same. Sometimes we take samples of different sizes for our two different populations, and that's okay. It just happens that they're the same here. So let's figure out what our values are. My X1 is going to be 200, which is my N value, times 0.57. So let's do that really quick. That is 114. Okay. And then my X2 is going to be 200 times 0.51. And that's going to give me 102. So that's going to be my X1, X2. And then my N's are both 200. So 114 and 102. All right. And then we decided that we have a two-tail test. So that means my p-value is 0.23. So let's do this in green. My p-value is 0.23. So if I take that, I have to divide it in half because this is a two-tailed test. So my p is going to be 0.115 on each side. And 0.115 is bigger than alpha, 0.05. So I would draw it like this. It's a bigger area. And if you look at the numbers associated with your test, your standardized test statistic is 1.2. So that's right here, 1.2. It's to the left of 1.64. 1.64 is higher, which means to the right on the number line. And because it's symmetric, we'd say also negative 1.2. Okay, but it's all the same. So you're in that big part of the distribution. So this is going to be a fail to reject H naught. So we're going to go to our chart. H naught is the claim. And we are failing to reject H naught. So that means there's not enough evidence to reject the claim. Not enough evidence to reject the claim. Okay. So again, failing to reject something does not mean that it's wrong. It just means we don't have enough evidence to reject it. So if the claim's H naught and I fail to reject, it's like, I don't know. I'm not sure. Okay. But there's not enough evidence to reject the claim. So that means that either it's possible that our hypothesis is incorrect, but it's also possible we need to take another sample and try this again, or some various things like that. So that's about it for this section. I will talk to you later. Have a great day.